Let's just dive in. So I was saying, so I was invited to go give a course on agile data governance to a master's in AI course, and all these folks from industry, they're learning all these great AI things to go learn, but they had no idea of, oh, I'm going to go back to my office and I'm like, oh, give me the data and I'm going to go do this cool AI stuff. I'm like, but that's not how it's going to go work. You're not just going to go get data. You need to go understand what governance is and where do you find that data. So there's this big disconnect on like, well, what you want to go do and what the cool, pretty pictures and stories are telling you. When you get into the reality, it's like, oh, the world is very different. And then, and at the enterprise level, it's like, oh, we're not cataloging tables that have names that look very nice and it's just 10 or 15 tables. No, we're cataloging like thousands of tables with tens of thousands of columns with words that make no sense to anybody. That's the enterprise world. And I think this is the balance that not everybody is aware of, and people dive in thinking we're going to go hit the ground running. And I'm like, wait, there's a reality that you have to go encounter there. And I think that's the difference.
Yeah, there's not
You
really a
need to
class
skill
of
for that.
college that prepares you for that. It's it would be called like 50 years of baggage, and you're thrown into the middle of it.
Yes. Yeah. It's funny too, because I think we do kind of a poor job of training data scientists on fairly standard tools like even SQL. I find most data scientists are taught to do everything in Pandas and not to use much more powerful tools that are just available within their companies. And yes, there's absolutely a use case for Pandas, but like most of them can barely stumble around in SQL. And that's really unfortunate. And so there is this big disconnect between enterprise data that we've been doing since the 80s and people wanting to completely reinvent everything, I feel like.
Well, yeah, I remember there was a time when SQL was, a four-letter word because, that was, obviously Python and Scala and all these other languages were, how you're supposed to do data. And SQL's, that's old school. I remember when data warehouses were, left for dead. It was like, thrown to a dumpster and, and lit on fire. Then somehow it crawls out and it's back more, bigger than ever. But there was definitely a time when data scientists, it's like the late 2000s, early 2010s, when all the stuff we're talking about now, building tools around. I mean, this stuff wasn't cool.
Yeah,
Right? If you're
it
doing
actually
data
had a
warehousing,
branding problem, right? Didn't they call it New SQL because they were worried that they were like, no, we're not like old SQL, we're New SQL, right?
well, yeah, and it's like it was data warehousing was kind of like the business mullet for a while. It's just it just wasn't cool.
So one of the things that have already come up a lot, and thinking about skills that data engineers should be focused on. Let's talk about data modeling, because I think, as you mentioned, right, you made this. You've been thinking. We've been all thinking about it. I've been talking about it a lot. So have you? You wrote this post on LinkedIn a couple of days ago. Right? You got like 100 comments about it. Like, why is it resurging? How much should all data engineers be learning data modeling, or should a certain type who are interested? And how do you actually start? How are you seeing this?
I would say that they at least need to be aware of its existence. Let's start with that. It was actually talking with he's a famous data modeler. I'll leave it at that. He's over the weekend about this, and he was like, "Oh, I thought everyone knew data modeling." I was like, "You'd be shocked." I would reckon probably Matt and I, our estimation is in our conversations with engineers and data engineers and software engineers and so forth, the number of people in data scientists, the number of people who know data modeling, I would guesstimate is like maybe 20% that we talk to, maybe, or acutely aware of like practices around it, how to do it, and so forth. People may have heard of it, but it's because he was actually commenting on chapter 8 of our book. He's like, your chapter is very confusing. I don't understand your sequence of why you put stuff the way you did. And I was like, I think it comes from our experience of talking to people and understanding that we kind of need to meet them where they are. We're introducing a lot of the concepts the way we did. Because I think there's a general lack of recognition of data modeling. He's like, why did you include Inman in there? And I was like, well, for one, Inman gets conflated with Kimball in a lot of cases, and there are different ways of viewing the world. Inman is very much a data warehousing paradigm, but unless you know third normal form, for example, you wouldn't be able to do maybe an Inman warehouse, for example, right? And but then unless you knew how to do what a data mart is, for example, it's sort of, you won't know the natural progression from that to a Kimball data warehouse, which is basically a data mart. And so that's why we included it in there. But it just that I think the lack of recognition is the first start in making people aware that, yes, you can model data. Because for the longest time, it was like wide tables or just sort of, reports were simply just, kind of made from ad hoc queries. So I would start there. Matt, what do you have to think add about that?
I think another major problem is that while there's a lot to learn from the sort of data modeling classic approaches like Kimball and Inman and third normal form, for the most part, you shouldn't be using those data modeling techniques with modern tools. So in other words, there is a technology element here. Third normal form doesn't play very nice with columnar databases, which is where technology has gone. And that's not to say there's
analytical technology.
Analytical, yes, absolutely. Analytical technologies, yeah. But that's not to say that you just denormalize everything. We used to like give some Google training for Google BigQuery, which is columnar, and they would just say, oh, we'll just denormalize your data. And I'm like, well, what does that even mean? I have no idea what it means to just denormalize everything. And so I think part of what we need to do is synthesize the classic techniques and then sort of update them to say, yes, you're going to have joins in here, but don't split everything into joins. Figure out when you use other types, when you keep things in one table, when you split things out. We just need a more intelligent, modernized conversation about some of these ideas, I feel like.
But there's a separation, though, I think, Matt, where it's on one hand, it is the if you look at the essence of what data modeling is trying to achieve, it's relating business concepts and definitions to relations among data.
Exactly.
Right? It's essentially what it is. But when you look back at the classics, when Bill came up with the data warehouse, it was because people were querying OLTP systems, and that was wreaking havoc on them. That's why he separated out data integration into a warehouse upon which you could do your analytics. And same with Kimball, right? It's taking data from a non-OLTP source or different sources and integrating them into a in this case dimensional model. But what's happened over the last few decades is I find very fascinating, because we're trying to shoehorn in these relational modeling or dimensional modeling techniques as well into technologies where I guess the same problems don't really apply as much, right? And so the thing that Matt and I have been talking about is, well, what's next in data modeling?
Exactly.
The essence of data modeling, I don't think, goes away, where you're trying to again achieve definitional coherence amongst your various data assets. But how you achieve this, I think, is open to I think a renewed way of thinking.
For sure, yeah.
When you have streaming data sets or graph databases or these or any number of new databases, it's like, do we have to religiously adhere to the old ways of doing things?
Well, I think when it comes to data modeling, there's two aspects, right? There is the people, the human aspect, and then there is the technical side. So data modeling is as much of a science as it is as an art. Oh, yeah. And I think you define a data model and you ask people, does this look good? Do you like this? Whatever. I mean, how do you even measure or kind of come up with some sort of metrics around, is this a good data model? You can come up with so many different types of ways, and you can ask different people. You can have qualitative approaches to go define that. From a quantitative approach, you can say, well, the query runs better, faster, whatever. Oh, but writing that query is so complicated. So then the query that is written is much more complicated than the model is. But if I change the model, then the query may less lines of code, but it may execute differently because of it's a row store or column store, whatever, right? But then you have to find this balance. But I want this data to be consumed by users, and hey, it's okay if they need to go wait 20 seconds instead of 2 seconds, but they get more value for writing a shorter, cleaner query. I mean, this is the types of stuff that we need to be thinking about. But how do we do that? We need to understand so much context around that. And if for data engineers who just go look at this without talking to the rest of the human beings, what are they going to go focus on? On the technology side, oh, it's a column store, it needs to run this fast, and I need to optimize, make sure it runs as fast as possible. So here it is, it's done. Please, data consumer, go look at this data. And they're like, what the fuck does that mean? I have no idea what to go do it. Well, here's a bunch of queries that you can go use, and then you start depending, and then you go back, right? Because it's this balance. And my rant basically is to say, it's not an easy problem, and it's not something that that will find technology to solve it. It really is. I think people need to really understand that it's an art and a science, and this will, and we've kind of just thrown it aside, and we can't.
Yeah, I mean, it's hard work, right? And I mean, if you read back and Kimball's book, building the our data warehouse toolkit, the step of dimensional. So the 4-step process of dimensional modeling. The first one is model the business process, right? And as he points out too, the uncomfortable truth about this is you have to gasp, go talk to people. It's much easier to sit behind your keyboard and and draw out diagrams all day about what a model should look like, but simply taking the time to go talk to people is that's something, again, back to the people, processes, technology. These are the kinds of skills I wish were taught more. Is and in our book we hit on this too, and at the end of each section there's a who are you working with section where we talk about sort of upstream and downstream. Who are you working with? Who and this is there for a reason, because time and time again we've rarely seen data projects fail because of technical reasons. I don't think I've ever seen one actually fail because of a technical reason. That's solvable. Where we've seen data projects fail countless times is, the data team isn't aligned with the people for whom they're supposed to serve. Simple as that.
Yeah, I completely agree. And to your point, Juan, about the thing about modern data modeling, what I often tell people is, instead of just trying to normalize everything, which is the old school approach, what you should do is look for data that's going to be recycled across many different queries and many different sub-organizations within your company. That's the stuff that should be pulled out. So for example, if I have customer data, you wouldn't embed that inside another table because you're going to use it all over the company to understand your customers, right? So that should be a separate table. And that is data modeling reflecting human processes. And that's, yes, you need scientific principles, exactly like you said, but then like, how do you, the craft part, like the art of understanding how your company works, that's one of the hardest things to actually achieve. It's not easy, especially for engineers.
And one of our friends, John, he said, the first thing he does when he starts at a new company is he asks, how do we make money?
Mm-hmm.
Oh God, you hit the point that I'm bringing up over and over again, which is what I'm calling business literacy. Every data professional, IT tech person needs to understand how this company makes money, understand the business process, understand the people around it, and then you understand where the data systems go on, and then you realize, oh, that's why you want that data, because I get all this context and I should be talking to the person on this side with that, right? Follow the money, understand how that goes. This is what we need, the business literacy. All data tech IT people need to understand business literacy, not just data literacy.
Mm-hmm. Yep. But it's underrated, right? I mean, again, if you go back to how, and Matt and I teach, and I think you teach as well. And the thing is, how often is this taught? Say you get an MSIS program or computer science or anything like that, right? These are notoriously, sort of shoegazy type degrees, right? Communication, I don't know that that's ever taught. Maybe you take a class in pair programming, you're in computer science, but MSIS, I think it seems like it's very much what you do, your capstone project at the end, where you might have to go get requirements, but that's, businesses will tolerate you for that just to, maybe get something out of you. And, but I've seen enough of these where, but I wish this was, but where I see it falling short is the students really, they end up frustrating the capstone sponsors because they don't know the questions to ask, or they can't ask them in the right way. And it's a hard skill. I can't blame the students, right? But asking good questions is it's very difficult.
Yeah.
I think that should be taught more.
Yeah, that's another key skill that we should add to our list here. So just a brief call out to our sponsor. So this episode is brought to you by Data.World, the data catalog for your data mesh, a whole new paradigm for data empowerment. To learn more, go to Data.World. And before we go to sort of our lightning round and start to bring it home with takeaways and things like that, one other topic that's super interesting is around the life cycle of data. And just curious from you, Matt, and from you, Joe, like, how do you think about the life cycle of data? And how do you think about the role of data engineers, both sort of, past and future, around the life cycle of data?
Yeah.
That is a good question. So I think early on, data engineers back in the early days of relational databases understood this fairly well. You bring in data, you transform it, you do something with it. And I think the technology obsession of the 2000s led us to lose sight of that. And so really that was part of our goal, was to like bring people back to those fundamentals of what data engineering is all about. And so that is the central theme of the book. And once you have that framework, then you can build out the details of how you're actually going to execute that, right? But you have to start with where you want to end up. You have to start thinking about what you're actually trying to achieve before you throw a bunch of technology at a problem. What are your thoughts, Joe?
And I think, it's interesting. When we wrote the book, we thought about, okay, so, earlier books like Designing Data Intensive Applications, I think was a great data engineering book, and still continues to be. And hopefully the next edition is fantastic. And Martin, incidentally, was Martin Klebman, the author of that book, was one of our tech reviewers. And so, we felt like, I think we're hitting on some good topics with our book. But why I bring his book up is interesting, because at that time, I think 2016, 2017, data engineering was in a much different place. It was still very technical. You still had to understand the underlying guts of the systems you were using. Whereas, fast forward to today, I mean, do you really need to understand, if you're running Snowflake, right? Do you need to understand how clocks work? You might, but I would wager that's or how Paxos works, or some distributed algorithm, right? Like I think it's good for you to know this stuff, but it's not necessary for you to do your job and run Snowflake, which is what a lot of data engineers run these days, or equivalent platforms, right? Databricks and so forth. And so what's happened is technology has become increasingly abstracted. It's SaaS based. If you're an engineer that happens to work at one of these companies, I would hope that you understand the stuff in designing data intensive applications. But if you're not, I would say that it comes down to lifecycle management now, right? And what Matt earlier alluded to with enterprise-y data engineering, it's now that you have the kind of the Maslow's hierarchy of needs, you're not focusing as much on system survival, so to speak. You can move up towards more self-actualization of being a data engineer. And what this means is, I think this is in part why you're seeing a lot of interest in things like enterprise-y techniques, such as governance and cataloging and quality, stuff that even a few years ago people would probably throw you out of the room for talking about it. It's like, why are you talking about this? Isn't data engineering. This is stuff that enterprises do. This is what are you talking about? But now you have the opportunity to do this, and what's happening is it's forcing I think a recognition of things that have worked in the past and things that will hopefully work in the present and the future, right? That's why you're hearing about data modeling now. I think it's to cover up for a lot of the maybe the past mistakes that we've kind of let languish as well. A good data model goes a long way towards, I think, eliminating the need for quite a few tools around the modern data stack ecosystem that now we're sort of monkey patching the lack of rigor. And so, but I think lifecycle management is a really big thing, and that's increasingly what we see data engineers focusing on. Where that leads to in the future, I think, is open to debate. I have my own supposition in the last chapter that data engineering might go away as a title.
Yeah,
so
that's interesting.
Let's follow up on that one.
Mhm.
What are the data engineering, data scientists, or now we're talking about analytics engineering. We're talking about data product managers. I like to call this also the knowledge engineers or the knowledge scientists. Like, where is this evolving?
There's a couple ways it's evolving, I would say, because of abstraction, right? So you saw this with data science. Every title you see in data science was actually a title that existed before, right? So, but it's sort of lumped into this thing called data. The same thing happened with data engineering, frankly. It's like this used to be ETL developer, BI engineer, software engineer, systems engineer, distributed systems engineer, and so forth, right? This is like now a data. It's kind of a catch-all term. But I think, we have a chance to move back towards, more specialized titles. At the same time, what's happening is, you're seeing a convergence of software and application development with data. I was talking to the last person I talked to right before our podcast. He was a software engineer and he works with data now. And he's like, yeah, I mean, a lot of the practices that I'm seeing are the two are melding together to the point where they may be indistinguishable from each other in several years from now. And then you also look at machine learning that itself is becoming more interwoven with both software and machine learning. So I think what you're seeing, what's been being, the practices that a lot of the big tech companies, I think, are trickling down to the masses. So those practices and the capabilities will be democratized to a large extent. And so it may morph into something that we call the live data stack, which is simply the sort of the real-time meets data engineering meets ML into a fast feedback loop where you don't have these like kind of artificial distinctions anymore. It's just a living, breathing, flow of data. But the life cycle is still there, surprisingly enough. That's what's interesting about it.
Things
so, Matt,
get simpler. A lot of these things actually consolidate together. And the thing that remains at the end is still the governance, the modeling, the working with the business and understanding the business questions. Those things kind of get left over and don't really disappear.
There, just kind of a heads up for next week's episode. We're going to have another author of an O'Reilly book, which is Ole. Get his last name, Ole Olison, who's the author of the upcoming catalog book.
Okay.
I've been chatting with him a lot, and one of the things he's brought up on life cycles is POSMAT. And this comes from the information library sciences. It's like plan, obtain, store, and share, maintain, apply, and dispose. And
nice.
It's going to be a phenomenal episode next week because he is coming in from the library and information sciences point of view. And
that's cool.
We've been talking about, like, when I talk to him, he's like, wow, yeah, that's true. And he's like, well, this is just our bread and butter in life sciences and in information library sciences. Like, and then you see the entire data engineering kind of community industry going on. They've completely ignored, and ignored in the sense because they were not aware about this stuff. And it's really hard to understand everything that's out there, right? And that's why we need to have these conversations and get people involved. And also why diversity is so important. Bring people from different areas.
I think of it like MMA, right? So like you have a library science person, and it's like I think that's cool. Like Matt knows. I think in terms of like fighting or South Park or something kind of weird that way.
Working out,
but but I think MMA is a really good example where historically it's been sort of bifurcated into like, oh, you're like a karate guy or you're a wrestler or whatever, right? Then the UFC comes along and you find out like it's none of the above. Like you got to be kind of good at everything, right? And so. But things evolve, and I think that's super cool. I think data mesh is the one thing we didn't talk about, but I think that because you're a data mesh company, and but I actually think that holds a lot of promise. And it's interesting. I've been reading a lot of books on actually the old historical ones on lean, like the original text, like lean thinking and so forth. What I find interesting is that if you harken back to DevOps, microservices, agile, a lot of them find inspiration in lean, really. And what that means is continuous flow, right? Batch is actually a bad practice in lean. That's an anti-pattern. So you don't do batch. And it's very low tech, right? At the end of the day, lean is about learning to see things. It's not technology. In fact, it's probably the lowest tech practice there is. But it yields a lot of value, obviously. And what I see is that whole mentality is trickling down into, software with DevOps and now data, and data mesh, I think is sort of a continuum of that where it's, in lean, you want things to be centered around, customers at the end of the day, not departments. So it eliminates silos, just like you would in data mesh. And so but I think that something like the live data stack actually facilitates that because it's a continuous flow of information among different domains, perhaps. That's what you want. Batch and queue is a cardinal sin, which is, the centralization of such, which is why, data mesh came about. So it's an exciting world, and who knows what will happen. I'm pretty stoked. Matt, what do you think about the future of data engineering?
Yeah. I mean, so what I'll say about traditional data engineering, like ETL developers and DBAs and everything, is that we've really had relational data until at least the 16th, going back at least to the 16th century, right? Like think about double entry bookkeeping, maybe further back than that. People are keeping track of transactions. We're always going to have that kind of structured data that we have to deal with. And we're always going to have batch use cases where it's like, I need to know about what happened with my business in the last 30 days. Venetian merchants needed to know how much merchandise came in on a ship and how much they got paid for it. But the evolution is along the lines of what Joe was saying, like more real time, and then just more and more unstructured data. I mean, look at what's happening with like TikTok, YouTube, Spotify, like podcasts, stuff like we're doing right here, we're just generating a flood of unstructured data. And we're still actually not very good at processing it. Like, we're very excited about these advances in machine learning, but there's a lot more to come in the next decade. And so that's what I'm excited about. I mean, okay, I'll say I wrote a newsletter, like kind of rant about this last week. I'm both excited and kind of terrified. I'm like, okay, but as our machine learning gets better, what are social media companies going to do to us next? Or what are we going to do to ourselves? That's what I'm wondering. So.
Well, this is an interesting point.
Yeah.
I'm not sure I agree with you, because yes, we're generating a bunch of more data, much more in unstructured data. I mean, pictures and sound and all that stuff. But what we're seeing more from the machine learning side is that we're not focusing on all the structured tabular data. Like, and I think if we look at machine learning, all the machine learning kind of data sets and people who do things is like, here's a bunch of pictures, but here's a bunch of databases, structured relational databases. Go do something with not just a table, right? Here is a table. Here's a database that has thousands of tables, and go do something with that. Like, I turn it into a denormalized table to do that. Well, for me to go turn that into a denormalized table, I got to understand what that means. And then we go back into like the issues that we're talking about today. And I think so. I've worked so much in my career on schema matching. And this is a problem that we've been trying to go automate academically. We don't even talk about this. Like, we don't talk about this today. Like, it's embedded somehow in transformations, but transformations take this entire blob of knowledge and you put it into some SQL query now, basically, which is a rules. But what you really want to go say is, I should be able to go think, hey, this thing X is actually mapped to Y, or some combination of what is the most granular thing. But we don't think about it that way because it's a hard problem. And second, we want to go automate that. And it's so hard to automate because we don't have clean labeled data to go do that. And I think that's the breakthrough that we're missing. And we won't be able to get there because we lack a lot of metadata. We have a lot of data, so we can do record linkage and stuff, but we don't have a lot of metadata. But having said all this, I think we're starting to now catalog and generate more metadata and keeping track of that, which we didn't do before. So that's why I'm very happily kind of getting more excited that we can actually have some breakthroughs on this. But this is a big problem that we're not looking into, and I think that's where we need to have more breakthroughs.
Yeah, I tend to agree with that. I guess what I would say is that I don't think the structured data side is going to get any smaller. I think what we'll see instead is just an expansion of data across the board. And to your point, like all the problems around tabular data are still really, really hard. I mean, this is something you worked on at a previous company, right, Joe? And it was really, really hard.
Companies like, trying to do auto ML, on tabular data. So auto ML on images and video, I think, is relatively simpler than tabular data. Because at the end of the day, the big difference is tabular data. All data is human generated, right? But at the end of the day, tabular is I would say tricky because it's human generated. It's got some sort of a purpose behind it that's different from free flowing text, images, audio, etc. Right, and that's where I think that the major differences. And algorithms are notoriously fickle at parsing this stuff. I mean, XGBoost is still, I think, like the best rated algorithm that came out a long time ago. But deep learning, I think, is it's just hard to pick out the subtleties in tabular data. It's insanely hard from a machine learning perspective. If you doubt me, go try it. Especially on unseen data sets, it's like very hard to make rhyme or reason out of it. It's full of mistakes. Tabular data sucks. I would say if you wanted to have a really fun time, play with tabular data. And so I guess the question is how much. The question I have is like how much data really does need to be tabular at the end of the day. Or are we doing that because it's convenient?
I mean, I think in our worlds, in our organizations, we live a lot with tabular data, right? I think that's what's always front and center. But I think, this is a good question. And at the end of the day, I always ask myself, like, we go back and everything ends up being tabular. I'm organizing this academic workshop in next year where we're getting together to talk about why do we always go off and think about all these data models. The graphs hasn't existed for so long, and there's so many versions of graphs and JSON and XML. There are trees and stuff, but we always end up back in tables, and it's fascinating how we always do that. but we go off and build all these things, but we end up back in tables. So what is it that us as humans, we just, why tables and humans? Like what is the fixation about this? I don't know, but
That's an interesting one. I mean, pixels are actually it's a table.
yeah. So this is this meeting that I'm organizing is called the Why of Knowledge and Data Models.
Oh, cool. Well, let us know when that happens. It sounds interesting. I'll have to pop in.
All right, this is something that we can keep talking for hours. You guys are
well, we might enjoy over some beers.
All the time. We look forward to actually doing this live one day, like in person. But we gotta hit our lightning round now. So let's move to the lightning round, which is presented by Data.World, the data catalog for your successful cloud migration. I'll kick it off. So you mentioned Inman, Kimball, they don't apply perfectly to the modern analytics landscape. Is there a new modeling paradigm that will emerge?
TBD.
I'll say there will be that. So yes,
yeah,
I think in the near future.
Right, but Joe said first TBD. Matt said first yes.
Matt says yes.
I think it's coming.
Yeah, I mean, I'm working on something right now. So we'll talk about it when it's a bit more ready. Yeah,
I like that. You'll have to share more as that keeps evolving. I liked your comment about like, well, how does streaming and some of this other stuff fit in? So I think it's interesting to think about the big picture.
Yeah, this is a clue. Yes.
Yeah, interesting. So second question, you both kind of mentioned about data engineering, like as the tooling gets easier, as the technology gets more advanced, the data engineering maybe is actually going to disappear potentially as a title or as a role. Curious about, we're seeing this rise of analytics engineering, and curious to see, do you see this sort of like moving to analytics BI, the business questions, a little bit more of that analytics engineering flavor? Do you see that as being a likely successor or a likely shift here? Maybe Matt, if you want to start.
What I'll say is that I see kind of a fragmentation of the data engineering role happening. And so maybe that's where the title is going to go away. I think analytics engineers are likely to take over a lot of work done by data engineers right now, especially making sure data is flowing appropriately into the business, into various teams. And then other parts of data engineering will probably either move under ML engineering or get some new title that's like something about ML-oriented data engineering that's a bit more specific. And then you're still always going to have these engineers that work on the guts of systems at Snowflake and Google and such. And so maybe we'll find a new title for them, because their job is really quite different from what most data engineers are doing. Like Joe was saying, most data engineers have evolved out of doing that. And yet, if you have these products, then someone has to work on them behind the scenes. Like you need hyper specialists who are working on these systems. And there's got to be some good title for that.
I mean, I don't see analytics engineering as being anything new. It's been around for decades.
Yep. What comes around goes around.
True enough.
Those who don't read our history are doomed to repeat it.
Oh, you just come up with different names for stuff, right? Data engineering is the same way. So, but yeah,
marketing is fun.
It is fun.
This is why I say we got to be critical, right? We got to be critical.
Yeah, for sure.
I got next question. Is the best way for a data engineer to learn data modeling, is it a hands-on experience, or can reading your book or a book do justice?
I don't think reading our book is going to teach you data modeling. It'll expose you to the concepts, but as we point out, there's a lot of books out there that like 500, 600 pages long. So do the hard work. I would say read the books, but also do it, like practice it, right? So.
Yeah, I'm going to agree with Joe on this one and say you have to go read the classics and then sort of synthesize them into something that you own through a combination of thinking and doing. And hopefully that story will improve over time, where there's more of a guided journey, so you don't have to go off on your own quite so much.
I mean, it's like reading a book on dating. At some point, you can read books on dating, or you can go on dates, and like, so.
Oh my God, this is perfect, right? Learning data modeling is like learning how to go date, right? You can go read the theory, but you got to go practice it.
Yeah, I mean, and please don't like read The Game or some stupid book like that. So,
you heard it here first. Go read The Game. Apparently,
I know guys who have read that book. I just sit there just cringing. I'm like, oh man, it's pretty bad. So,
all the secrets.
Still single after 12 years.
All right, last lightning round question here. So, the 2010s kind of saw the rise, especially towards the end of the decade, of the data scientist being this like sexy, awesome, critical job. Um, maybe data engineering longer term is going to disappear or something like that. But in the shorter term, like, is that really actually that sexy, critical job of the early 2020s? Is it data engineering?
I would say it has been for the last like 2 to 3 years, and I think the open question is around economic transformations that we might not be going through right now. I think that's we've seen a huge talent shortage since maybe at least 2017, 2018, maybe going back further if you include big data engineers. And the question is, I don't know, if we go through a recession or something, does that change the conversation? Maybe it does.
Well, I mean, the conversations I'm having with people, or cost management comes up a lot. FinOps, I would say, like any data professional, engineering or otherwise, that understands cost management, you're gonna stay employed, hopefully, unless your company implodes. So, which could also happen. But
that's a good skill to add to our list here.
Yeah, I just added
cost management is a huge one. I would say cost engineering like that. The next wave of startups, I think, that in the data space are going to be at cost management for cloud tools. Is so opaque.
Yeah.
Yep. Definitely seen
I mean, the problem is that there's no proper training for this. And if you kind of came from the previous generation of data engineers, then you were taught performance management. So it's like, how do I optimize more Oracle systems or optimize queries, not cost optimization? It's a different problem.
Yeah. And that's when you have to think about people and money and more things, right? And that things changes. This is
what's the ROI, right?
Yeah, exactly. Excellent point. All right, Tim, take us away with takeaways. Go first.
All right. So, Matt, you kind of kicked us off with mentioning shiny object syndrome or Magpie Syndrome when we talked about, where data engineering or data engineers might become very kind of, either distracted or very invested from a technology angle around tools. And I think y'all kind of brought up, why did we get into engineering in the first place? It was like being able to do cool stuff with cool technology. And so therefore we're technologists at heart. Like we're interested in this discipline of applying technology, and as technology evolves, that's exciting. And, we want to jump in on the new stuff. And also y'all mentioned about, resume driven development and sort of how, as this new tech comes out, we want to take advantage of it, putting it on your resume, whether it's for your own benefit or because employers are looking at that kind of stuff, that it becomes a focus. And as we adopt new technologies as companies, as enterprises, we want to, we want to implement Airflow or something like that. It's okay. Well, let's hire somebody who knows Airflow, right? And sometimes it becomes easy to kind of go in that direction. Or you're wearing a Coursera shirt, right? Like we can take some courses and we can pick up some new skills. So it is nice how easy it is to do that now. And there's a little bit of this lack of emphasis on people and process, and tech is becoming more and more the easy part, and that leaves open-ended some of the hard stuff, which is more the people and the process stuff. We talked a little bit about history, right? Looking back to especially the big data, Hadoop kind of phase of things. And that was a great example of where technology was a big part of the conversation. And as we've moved past that phase, now we can kind of look back with open eyes 2020 on kind of what it really was. And, it was valuable, but, there was a bubble that happened, right? And I think now those who know their history want to see that not happen again in the future. And we talked about, what skills data engineers are really focused on and can, get a lot of value from. And some of the ones that we wrote down were assessing questions, like really being able to look at questions and answer them and figure out how to answer them. Assessing technologies based on business problems. So not just technology for technology's sake, but the applicability of technology given the kind of problem that you're trying to solve. And this mention of enterprise data engineering. So, a lot of this activity around modeling, around cataloging, governance, schema, there was a mention about Maslow's hierarchy. Maybe some of the like basic blocking and tackling now is being made a lot easier. We're addressing a lot of that stuff, and now we're being able to handle these and focus on some of these things that are a little higher up the hierarchy. So, I think that's a good thing. Juan, what about you? Takeaways?
Well, let me continue on the skills one, right? We talked a lot about data modeling, right? This is something top of mind of all of us right now. I like you said, you're guesstimating that 20% only data engineers around only 20% of them know what data modeling is, right? And I think this, and I would agree with you on this. We really need to kind of update the classic techniques to the modern world of analytics right now. We were talking about how it's just the science and an art, and there's the stuff that we need to go kind of figure out given the state of today. We need to learn how to go talk to people. Communication is key. Like, where is this happening? Where are you actually teaching this? Like, if you get a computer science degree, you're not. I did computer science for a long time. No communications. But is this happening in MIS or stuff? Like, I think this is a key thing about communication. And one that just came up was cost management. This is we focused before on performance management. Cost management is next. We talk about what's next for data modeling. And hey, Joe, you just put a hint there, right? Is it something about streaming graphs or whatever? So, what are the new paradigms on data modeling? Something you said that I fully agree with. Data projects don't fail for technical reasons. It's because the data teams are not aligned with the people who need to go serve. So they fail for the people in the process, not for the technology. The whole life cycle of data, right? In the early days, it was well understood, right? We had to go bring data, we transform it, we go use it. But I think we've given so much technology right now, it's really distracted us. And we need to go focus on kind of self-actualization of data engineers. And now we have cataloging and governance and modeling. So how does this fit in the life cycle of data? We have all these roles where there'll be a consolidation of these roles in the future. Yeah, looks like I think we agree that there will be. And then finally, we touched about the tabular and unstructured data. And it's so hard to pick up the subtleties of tabular data. And I think personally, there's a big challenge and future opportunity there, and how much data actually needs to be tabular. One random thing that you said earlier on, I love this. Legacy is a condescending way to refer to something that makes a lot of money. I love that. I'm going to close with that. Matt, Joe, how did we do? Anything we missed?
That's good.
This is a great chat. Thank you for having us on.
Fun.
All right, throw it back to you guys. 3 questions. What's your advice about data, about life? Who should we invite next? And third, what resources do you follow? People, blogs, newsletters, books. Obviously, go get your book, but what else?
Matt, do you want to give the advice part?
Yeah, I'll just give advice for aspiring data engineers. And it goes back to an internal conversation that we had at Ternary Data this morning. We were talking about lifelong learning and how you really have to be a self-learner and a lifelong learner to succeed in data engineering. And so going back to the conversation that we were just having about people and process, I feel like if you want to be a successful data engineer, you start by learning the people and process stuff, which hopefully you can learn from our book. Now, this is what I'll tell you. Our book will not teach you data engineering, right? That's truly bizarre for a book that's about the fundamentals. Rather, it's meant to give you foundations so you can start that lifelong learning journey and get into the profession. So learn about people and process, learn the big picture, and then embark on the journey of actually learning the technology and learning the practices to be successful, if that's what you'd like to do.
As far as who you'd invite on, I'm going to recommend Bill Inman. He's working on some really cool stuff with text right now, and he's a very good friend of mine. I'm always inspired by him. I think I can only hope that when I'm his age, I'll be contributing a fraction of what he is right now, on a daily basis to the data world. I really feel like he's still at the top of his game, which is it's really cool. So
I would be truly honored to meet him, and I'm yes, look forward to connecting with you and have him on the show for sure.
Yep,
thank you.
Awesome.
Yeah.
And finally, what resources do you all follow?
Let me see. Lots of
I'll give you
stand-up
a short list.
comedians.
So Ben Stansel in the data space. I think Ben is awesome, and he's very focused on the fundamentals. I'm going to give you 2 other names that you're probably familiar with that are not technically in data. One is Kelsey Hightower. I think Kelsey Hightower mostly worries about containers and other technologies, but he's super, super pragmatic. And so I think he has a lot of insights that impact data as well. One of my all-time favorite Kelsey Hightower talks is a talk he gave about AWS Lambda when he worked at Google, which is an Amazon competitor, of course.
Yeah.
Like I always feel like I learned something from his talks about data, even if he's not focused on data. One more name on the FinOps side is Corey Quinn. You guys know who Corey Quinn is probably. So totally focused on cloud cost management, very entertaining. One of my favorite all-time data YouTube videos is his Happy Birthday to Larry Ellison video, but be warned, it's not safe for work. So
Yeah.
you know which one I'm talking about.
Yeah, I know which one you're talking about. People I'd recommend following. I mean, there's a lot, I think in the LinkedIn filter bubble we're all in. I actually you guys are two I'd recommend, and I think it's awesome. Ethan Aaron, I like a lot of the stuff he's coming up with these days. There's I know there's a lot of people I think of. So just follow. I would say follow all of us, and then you'll be exposed for better or for worse to some great data people. So
All right, and then finally, go get your book.
Get the damn book. Yeah,
I just been opening it up just random places, and I'm like, oh wow, just even I'm very impressed. I'm really excited.
It's a gold mine. I mean, I hate to be shameless about our book, but I mean, a lot of people have read it at this point. I think it's universally gotten like a really good recommendations. I think the only fault of it is like somebody wrote on Reddit, and it's Reddit, so take it for what you worth. But it's like, oh, I already knew all this stuff in the book, so I didn't really get anything out of it. And I was like, it's more of I think an admission of how awesome you are, but it's not a knock against the book, right? It didn't make you a worse person as a result. So
I just opened up this right now to this page 196 on storage. You have a magnetic disk. Right. My dad started. My dad didn't finish his PhD, went off to IBM in the 1970s, and worked on this a lot. His PhD was all applied. So this is so cool. You guys even go into hard disk drives and stuff. So that's awesome. All right. Well, next week, as we said, we're going to have Ole Olson. He's the author of the upcoming O'Reilly Data Catalog book, and I will be live with him. I'm in Europe next week, and I'm going to be with him. That's going to be fun because we're probably going to be 11 p.m. live. Well, we're in Europe drinking some wine, and Tim will be 4 p.m. over here, so it'll be a fun conversation. With that, thanks as always to our sponsors, Data.World. We get to do this because Data.World supports us, the Enterprise Data Catalog. Thank you, Data.World, and thank you, Joe. Thank you, Matt.
Of course, anytime.
And also go follow your podcast and everything. We love it.
Thank you.
Yep.
Yeah, Monday morning data chat. Cool. All right,
Cheers.
thanks, guys.